Now, when we begin to introduce the topic of, I suppose, complex numbers, real and imaginary numbers, we say, well, where does this come about? And basically where we get this idea of a complex number is when we initially started with our quadratic, okay, that we're very familiar with. Just say we have x squared minus 4x plus 5 equals 0. Okay, and we go to apply our lovely quadratic formula to that because we've tried our big X method and that doesn't work out for us. So we know minus b plus or minus the square root b squared minus 4ac all over 2a. I'm sure you'd be sick of hearing that. But if we apply that, you're going to get x, just nice and quickly, x equals minus 4 plus or minus square root minus 4 squared minus 4 times 1 times 5, all divided by 2 times 1. Okay, what does that simplify down to? Well, we can get x equal to 4 plus or minus, I believe we get the square root of minus 4 all over 2. And it's this idea here that I'm going to highlight. We have the square root of a minus number. Now if you type that into a calculator, you're going to get an error because you can't get a square root of a minus number. And this is where we introduce that idea of, so how do we write this answer? Well, we've got to introduce this idea of j equals the square root of minus 1. J represents this imaginary number, just so we can write it a bit better. Well then, how does that affect our square root of minus 4? Well, that can equal the square root of minus 1 multiplied by the square root of 4. So we can break that down into this representation of it. So then that ultimately means we can have j times the square root of 4, which ultimately gives us j2. So then we can go back, now that we've sort of allowed ourselves to represent an imaginary number, this kind of imaginary number that we get dealt with here. We can then represent, well, x equals 4 plus or minus j2 all over 2. 2 will divide in twice and once. So then that will imply x equals 2 plus or minus j, which can also be written as x equals 2 plus j, and also x equals 2 minus j. So you see, this is where this kind of complex number comes about. Real area of importance to note is that we let j represent our imaginary number of the square root of minus 1. Then if we can start breaking out the areas where these, complex numbers or imaginary numbers come in, we can represent them in terms of j. And then ultimately we can take the solving of our quadratic on further, and we represent a complex number, which is what we have here. And a complex number has a real part, just throw this in down here at the bottom, a real and an imaginary j part. Okay, so they're important, and that's what a complex number is. And we're going to look at, we've seen how they've come about, and now we're going to look at how to add, subtract, multiply and divide them.